let's take another look at graphing trigonometric functions and consider not only the patterns for sine and cosine, but some terms that we use with periodic functions, which are functions that repeat a pattern. And those words are period, amplitude, and phase shift. Okay, you see in the graph to your left, the red graph is the graph of sine of x, and as we pointed out in an earlier video, sine of x has x-intercepts at 0 and the quadrantal angles that are multiples of pi. So 0 and, as I say, the pi guys. And cosine of x is the green graph, has x-intercepts at the odd multiples of pi over 2. Okay? And you can see that they both have range, -1 to +1. They both have domain, all real numbers. They each consistently repeat a pattern, and that's why we call them periodic. And if we measure the length of the repeating pattern, you see that for, let's try to do this in the same color here, for the sine graph, one full pattern fits between 0 and 2 pi. Another pattern fits between -2 pi and 0. The horizontal length of the repeating pattern is what we call the period. So the distance between where the cycle ends and where it begins, whichever one you pick, that distance is the period, the horizontal distance. Okay, so the green graph, this may be a little harder to see, the cosine graph, you can either pick the same cycle as sine, but what we're going to do is pick a crest to a crest and achieve the same thing. Okay, so I'm just going to kind of start both of my basic cycles near the origin. And this guy starts on a crest at 0, 1. Well, you can see that the length of the pattern from crest to crest, either direction you look, is 2 pi units. So the period of cosine is also 2 pi. Okay? The definition of amplitude for a periodic graph is technically the maximum value of the function minus the minimum value divided by 2. And actually, you would always consider this a positive measure because it's a sort of distance. Notice how sine and cosine oscillate is the correct word around the x-axis. So they bounce through and down and through and back up, and they're equidistant from the x-axis. Okay, but the total height of each graph, whichever one you want to pick, from bottom to top, is 2 full units. Amplitude is what we refer to as half of that height. Okay, so the amplitude for sine or cosine is actually a value of 1 unit for the standard basic graphs. Okay, but if you're ever in doubt, just use the simple formula max minus min over 2. Now this concept of phase shift is kind of different. We've talked about horizontal shifts, and a phase shift is somewhat of a horizontal shift, but it also can encompass what we refer to as a horizontal compression. And I'm going to give you some tools to deal with that in just a moment. But the phase shift, let's think about this. If I look at the red graph and it's passing through intercept 0, 0, if I shift it back pi over 2 units, then the red graph sits directly on top of the green graph. So I could say that the graph of sine of x could become the graph of cosine of x if I shift it back or left 2 units. That's what we would mean by a phase shift, when you can tell where the graph has had a net shift, taking in any horizontal compressions as well. Now this will make sense more later, but right now the standard graphs do not have a phase shift. It's only when we move them horizontally or shift and stretch or compress them horizontally. And I'll do that in a separate video. Okay, so again, to review, know the basic shapes, understand the components of the beginning of a cycle and the end of a cycle, whichever one you want to pick, sine or cosine, okay, and look at those characteristics. So for example, I would say that sine begins and ends on x-intercepts, and halfway in between is an x-intercept. From left to right between the two intercepts is a max of 1, and from left to right between the second two intercepts is a min of -1. For the green graph, same thing. It's a cosine, so I'm going to start on the 0.01, which is at the top of the crest. 2 pi units later, I'm going to be back at the top of a crest. Halfway in between these two, directly halfway, is a trough, or the min of -1. Halfway between each crest and trough, or trough and crest, is an intercept. Okay, so get those basic patterns down in your mind, and the rest of what we do will be a whole lot easier.